So yes, I'm going to give you an overview of basically current understanding of when people arrived in this part of the world, so subtropical Eastern Australia, but also give you a broader context of where people came in to Australia, the dates that are starting to emerge and starting to firm up quite nicely, and some of the potential impacts or relationships with the broader environment. So I just like to sort of highlight my areas that I work at. So obviously School of Earth and Atmospheric Sciences. There's also a new centre that's being developed at QT called the Resilience Centre, which looks at environmental resilience. So cyclones are very at the fore of that, so natural hazards and how we are resilient in the face of those hazards as well. And I also maintain links to my former workplace, UQ, at the School of Environment, so I'm an adjunct academic there as well. Also like to acknowledge the traditional owners, so the Yagara and Turrbal people here, and lands on which we're meeting, but also the First Nation traditional custodians across a lot of the regions that I'm going to discuss today. So Arnhem Land, Wet Tropics of northern Queensland, central Queensland, and particularly the Quandamooka people on Stradbroke Island, and the Butchulla Ungari as well, and I'll be coming back to those areas in particular. So what I'm going to discuss today, firstly, is present an overview of human arrival into Australia. So particularly evidence is firming up really well that people were probably in Australia and northwestern Australia by about 65,000 years ago. So a good 20,000 years ago to what the date was thought, probably about 20 to 30 years ago. There's also interesting debates about how people populated Australia, so demographic process, so how long did it sort of take for people to spread? And I'll touch on that as well. And what was the type of environment they sort of moved through to get to Australia? And we're actually doing a little bit of research in Sumatra on that at the moment, so there'll be a little bit of fresh research on that as well. I'll then give the context, so the last 65,000 years. I'm going to look at the work that really got me into this area, which is looking at an ocean drilling program, deep ocean core off Cairns, basically, which provides a sort of long-term perspective of what the environment looked like over 100,000 years and plus, and gives that a really important context. And then focusing on Minjerribah, North Stradbroke Island, and look at a couple of new Pleistocene sites that have emerged and been published. And then discuss some of the future research that's occurring in southeast Queensland as well. And obviously I'll leave plenty of time for questions. So when we look at where people came in from Australia, there's actually two key routes that are supported. So obviously coming in from Indonesian archipelago, at the time of arrival with lower sea levels, this was a much greater area of dry land. And this was a key area in which people would have moved down into Australia. And they either moved through Sulawesi and PNG, so the northern route, or coming through Flores, Timor, and then into northwestern Western Australia, Northern Territory, at the southern route as well. That's still being resolved. So we are actually missing dates in this area. So we actually don't have a 70, 80,000 year date. People would have been there, but we haven't found it yet. And there's still a lot of interesting research occurring there as well. And obviously, this was a time period of lower sea levels. So probably around about 85 meters lower than today. So that sort of shows you what the coastline looked like. So no Arafura Sea, and a lot of that northwest shelf exposed. And that would have probably acted as a sort of area of arrival through there. As well. And then what type of environment did people move through? And there's a debate about whether Sunda or that Indonesian archipelago was open grassland, savanna corridor, which is very similar to Northern Australia, or whether people were adapted to living in rainforest. And we're actually getting evidence that people in Indonesian archipelago were living in rainforests at that 40,000, 50,000 years ago. And we actually have some really early rock art that's emerged, I think some of the oldest in the world, which was dated in Indonesia at about 40,000. But there's still a lot we need to resolve about that. So in terms of Savannah Corridor, I've actually done a little bit of work in Singapore, one of their last remnant wetland areas, which provides evidence of environmental change back to around about 25,000 years ago. It's a site called Nisoon. It's quite close to one of the reservoirs there. Very complicated stratigraphy. Key thing I want you to note is that we've got a date of around about 20 to 25,000 years at the base, but it took a lot of effort to sort of tie everything together. And the reason why this is interesting is that it provides evidence of this savanna corridor. So if you look at that palaeoecological or grass, there's a lot more of that time period. So it does suggest that there was this area of grassland that people could have used to move down, extrapolating it back to 60,000, 80,000 years, but we do have evidence of that as well. So that environment is available for people to utilize, and might have been an environment that's more typical of, say, Asia, so Indian subcontinent, Africa as well, that people would have been more familiar with, and may have facilitated the movement into the savanna country in Australia. But as I mentioned, there is also evidence emerging that people were living in rainforest in Sumatra. This is part of an Australian Research Council Discovery Grant led by Julian Lewis, who's based at Griffith University, and that I'm involved on. The project's focusing on cave sediments there. I'm extracting pollen out of the sediments there as well. And interesting enough, we do get good pollen yields. And it does cover that time period of interest for human arrival. So it goes back around about 130, maybe 150,000 years at the base there, to around about 30,000 years, basically. So that's that key time period. Interesting to note there's a lot of evidence of rainforest there. And if we find fossils, and there were fossils there, not only modern humans, but also Homo erectus people, and there might be other, like the hobbit and other human species there as well at that time period. But it was rainforest. Looks like people were living in that environment, but around that sort of 80 to 60,000 year time period, the landscape dries out. So you see this increase again in grass. So the sort of goldenrod color there. And even sort of colder conditions. So we see an increase in sort of montane taxa are occurring, and the rainforest comes back basically. The other interesting aspect of this is this last area of the graph where we see an increase in burning. And again, this is literally, I finished getting this together a couple of weeks ago, but that could reflect people being in the environment, burning landscape and influencing landscape as well. So we need to sort of, a lot more to come on that side of things as well. But I think that's starting to fit in quite nicely with the story in Australia. Now, the key site that's really pushed back that age of human arrival in Australia is Minjerribah. This is work undertaken by Chris Clarkson and others from UQ, and basically has a optical stimulated luminescence dating age. So this is a particular technique that looks at sand grains. Basically, when the sand grains are buried, the electrons get trapped in sort of the crystal lattice of the quartz, and then acts as a sort of automatic clock. So when you take that sand grain out, you excite the electrons, it releases light, and you can measure that wavelength, and it basically tells you how old the sediment is. One drawback is you can't expose it to sunlight. If you expose it to sunlight, basically it resets the clock. So people who work with OSL need to work in dark rooms and red lights and things like that, and are very sort of nervous about sand grains being exposed as well. The reason why that's important is that radiocarbon dating only goes back around about 50,000 years, so it extends that boundary through there as well. But you can also compare it with radiocarbon dating as well. And this date has been directly associated with artefacts, so it's not indirect evidence. We've got artefacts there. Chris and colleagues are very confident about the age, that there hasn't been turnover. There is a lot of debate about that, so some archaeologists don't agree with the date. It suggests it's probably close to 50,000 years. Personally, I think it's a pretty reliable date, and seems to be stacking up with other sites across Australia as well. So even if we excluded this date, 50,000 is generally accepted by the scientific community. So it's well past that 40,000 year time period. And one of the other obviously interesting questions, once people arrived at Minjerribah, so up here, how long did it take for them to spread across the rest of Australia? And again, this is a dramatically different environment. So you didn't have Arafura Sea, Gulf of Carpentaria was dry land. There was a large lake, freshwater lake system there as well. So dramatically different environment to what we see today, just in terms of sea level. as well. So these are the dates. That's the 65,000 date there, basically. So there are a lot of dates that have been thrown at it. OSL generally costs around about $3,000 to $6,000 a day. So so that sort of improves the reliability through that profile, basically. So that's the youngest sediment there, and then there are all the dates going through the profile, the archaeological profile, basically. So there has been some work done on the rate of occupation. So basically, they've used some stochastic modelling to sort of spread how long would it take for people basically to get from northwestern Australia all the way down to Tasmania, eastern subtropical eastern Australia as well. And it suggests it would have taken about 156 to 208 generations, which sounds like a big number, but essentially about 5,000 years. And that's just based on sort of the population spreading at probably about 0.8 kilometres per year, basically, to fill the Australian continent. Now, it wouldn't have been high population density, but that's the rate occurring there as well. And this has been based on two assumptions, so 60 to 55,000 years. So there are a number of questions here. And one thing I'll stress firstly, I don't have the answer to these questions. They're still very heavily debated. So megafauna extinction, which I'll come back to, fire, and habitat change. So they're all really important aspects that are still being worked on. And this part of the world, I think, forms a really important part of answering those questions as well. So that's where I'm really coming to that context of what the environment looks like. And then we can start to look at the environmental impacts. Also, why do we have an apparent absence of sites in coastal Eastern Australia? And I'll show some evidence of that shortly. But again, we're starting to break that down. So I don't think that's going to be as big of an issue as it was probably 5 to 10 years ago. So I'll come back to a couple of new sites shortly. And probably the other really important thing, so we're facing climate change now. So how did people adapt to that? What lessons can we learn from what First Nations people were doing at that time period? It's a long period of time, and we do see similar, if not more severe, rates of climate change at that time period. So if we go back 20,000 years ago, it was 6 degrees cooler, sea levels were 120 metres lower. So dramatically different environment. If we can keep global warming to about 2 degrees, basically, you know, it shows a dramatic impact that those temperature changes and other environmental changes can have as well in the Australian environment. So this is the model. This shows you sites that are sort of 45 to 65,000 years. So there's Minjerribah. We see some up in northern Queensland, a lot in WA, Willandra, Lake Mungo, and that area as well. And also there are some important sites in Tasmania as well. So people were in Tassie probably around about 45,000 years ago from the archaeological evidence. So it might be a little bit sooner than that. So, but you'll notice this big gap pretty much from Atherton Tableland down to Sydney, essentially. And that's, you know, where are the sites? So to give you that context, so as mentioned before, my PhD was focusing on the wet tropics of Northern Australia. So around Cairns, Atherton Tableland in particular. This is a very unique environment in terms of Australia. So most of, a lot of Northern Australia is dominated by savanna country, so utes, gum trees, grassy areas, very fire-prone environments. The wet tropics, by the name, has a lot of rainforest. These are remnants of rainforest that once dominated all of Australia and have contracted this area and along the east coast as well. We also have mangroves, which tell us about sea level changes, which I'll come back to, and wet sclerophyll forest, so a mixture of eucalypt forest and rainforest understory, basically, as well. And then an extinct community. So this community disappeared around about 45,000 years ago, so coincides with that time period of human arrival, and it's dry Araucarian rainforest. So the forest that we find at Bunya was also found extensively on the Atherton Tableland and disappeared about 45,000 years ago. Peter Kershaw, my PhD supervisor, suggests that's associated with people changing fire regimes, burning landscape, and replacing it with wet sclerophyll forest, basically, at that time period as well. But it's a little bit more than people, and that's where the ODP comes in, which I'll come back to as well. So ocean drilling program is part of the International Ocean Discovery Program. It's an international organization which basically, or consortium that goes around the world and drills big holes in the sea, basically. So ODP 820, which I worked on, was part of leg 133, which was actually collected in the early 1990s. So there's archives of these that you can go collect more samples on, and basically just located off Cairns, off the Grafton Passage, and provides a really detailed picture of environmental change. Not only in terms of the pollen and charcoal that I've discussed, but also marine evidence as well, and age of the Great Barrier Reef and so on. So it's on the continental slope. I mentioned that. And the reason this program or this leg occurred was basically to look at how old the Great Barrier Reef was, and also the evolution of the Queensland Plateau, so that area off the reef. And we have sediments that go back maybe 30, 40 million years, basically, from these records as well. So there are around 14 cores. I'll just mention ODP 820, but there are a number of other cores. In 1990 was when they're collected, and they're still being worked on today. So the 820 core is 400 meters in length. I've done 65 meters for my PhD. I'm up to about 130 meters now. So I've slowed down a bit with other projects and things like that. Don't know whether I'll get the 400 meters, but you know, I might get up to 200 meters there as well, which will probably be around about 1 million, maybe 1.5 million years, basically, of a high resolution record. So this graph just shows the location. So ODP 820, you can see that is basically just off Cairns there. We have had a look at other cores that go back different times. I've had a PhD student who looked at the Pleistocene about 3.5 million years ago from not ODP 820, but ODP 822. But there are also cores off Townsville that are quite interesting. And there's an archive in Japan. It's the easiest way to get samples. I just send a request to the archive, and they post samples back to me that I can start looking at, basically. So all the hard work's basically being done. But this just basically shows the length of the cores and how they stretch across the Queensland Plateau there. We also have marine environmental evidence. The key one I want you to note is this change in the oxygen isotope record. So you sort of see that shift in direction there. That has been attributed to around about a 2 to 4 degrees warming in sea surface temperatures. So temperatures have warmed up. It's been used as a possible explanation for the development of the Great Barrier Reef, that would cross the threshold where waters were warm enough there for the Great Barrier Reef to basically take off, probably around about 300 to 400,000 years ago. The other one you'll see are these peaks in sand, that's magnetic susceptibility, and then peaks in sand. What this is reflecting, as we've had that increase in temperature, is probably Northern Australia, and probably Australia generally drying out at that time period. So this was the environment that people arrived into. So there's a whole nother story from the marine geoscientists about the Great Barrier Reef history, but again, it does seem to be forming up at around about, forming over the last 300 to 400,000 years. And there is a link potentially with southeastern Queensland. So one of the thoughts of how it was able to form was not only temperature, but also sediment. So corals don't like murky water. Gari developing where it is, and the giant sand masses basically trapped that sand, cleared up the water quality, and helped to sort of enhance the growth of the reef as well. And we can see this in sediment records. So this is an ODP 820 record. Just look at the general patterns, but we're looking at clay, silts, and sands, and calcium carbonate. But essentially, you sort of have a pattern there of sort of more consistent values there. So probably a little bit more sand, but generally a lot more consistent in terms of the average values. There's sort of a transitional phase around about 300,000 years ago. And then you see these really clear peaks and troughs there as well, particularly in the sand data as well. So it's suggesting that there's been a change in the sedimentation process. And I would put that down to basically the Great Barrier Reef being there. So it's channeling flows and things like that, basically, where it wasn't present and you had a diffusion of sediment out on the shelf prior to 400,000 years ago. But what I've been focusing on is the rainforest history or the vegetation history. So these are the things that I look at, which is fossil pollen. so the different sizes, shape, and characteristics tell me what the parent plant was, basically. So this one here is Araucaria, the bunya, and hoop pines. We've got Elaeocarpus, so quandongs, gum trees, so eucalyptus. Let's see if I get my mangroves right. Red mangrove, Rhizophora. Fern spores, so the ground ferns. We have extinct species, so this is a Dacrydium species. It's actually related to a species, and we know this from the pollen morphology, to a species that's found in New Caledonia that's now extinct in Australia. We have palms, grasses, tree ferns, Cythea, and sedges, Sarcoraceae, basically. But there's a whole range of different things that I use to sort of reconstruct and create diagrams such as this. So the categories we have here are rainforest gymnosperm, so that's the dry Araucarian rainforest. So the vegetation around the Bunya Mountains basically is the equivalent of that. Rainforest angiosperms, which is what dominates the rainforest around Cairns today. And then the sclerophyll herbs and sclerophyll arboreal taxa of the savanna country eucalypt forest vegetation basically there as well. And what you'll notice is that the dry rainforest decreases and the sclerophyll taxa, your savanna, increases basically there. There's also some interesting cyclical relationships. So every time we have a warm wet period, so MIS1, which stands for marine isotope stage 1, it's a warm wet period that we're currently in. Our rainforest comes back. And when we're in dry conditions, so MIS6, you see an increase in the sort of sclerophyll taxa and or the dry rainforest as well through there. So that reflects that cyclical nature. But the other change we have is this increase in burning. So charcoal just through there, and evidence of drying out. So our ferns decrease in 2 sets there, along with that sort of longer term change in our rainforest gymnosperms. And we also see a change in our mangrove response. So mangroves respond to sea level. So they're generally high during our interglacial periods, MIS15, and stay high. But when we sort of hit MIS 8 or 9, they peak during the sea level transgression event. So when the sea level rises, our mangroves come in and basically dominate. And I could always tell when I was going to have a mangrove peak. I'd have mangrove roots in when I was sieving my sediments, basically, and then they'd line up pretty much with those peaks there. So there's a change in the dynamics there, which again is probably linked to the development of the Great Barrier Reef. So just to summarize that a little bit further here, we see a decline in these rainforest taxa. I've sort of grouped the bunya pines there as well there, but Araucaria dropping off, podocarps, palms, Zeum, which is the native Myrtaceae rainforest taxa, so lily pillies, and Macaranga melotus, which is another common rainforest species, drop off. There is a little cyclone story here. So we also see an increase in Cuninaceae and Elaeocarpus, which favour wetter environments. So what it's suggesting is that while things are drying out, we're seeing increased climate variability as well. So we are getting sort of more intense floods, rain events, and probably more cyclones hitting at that time period. I'll come back to the driver of that shortly. If we look at sclerophyll taxa, it's a similar story. But in this case, our taxa that decrease are shea oaks, casuarina, native pines, colitis, and Asteraceae daisies decrease as well. And what increases is our fire-adapted taxa, particularly eucalyptus and grass. So again, that increase in burning is occurring. This isn't human. This is a natural factor coming into play. So I'm not suggesting that people were there 300,000 years ago, but and I do have a natural factor that comes into play. And then if we look at wetland taxa, again, we see this drying trend occurring. So fern spores particularly drop off. And interestingly, we have an increase in triglycan, which might again be sort of reflecting that change in dynamics linked with the Great Barrier Reef. And then that's that sort of cyclical change in our mangroves. So from that sort of constantly high during interglacials to only responding during transgressive events, basically, those sea level increases. So to summarize that, we see clear cyclical trends linked to orbital forcing. So all of our climate can essentially be related to how the Earth orbits the sun. There are these big 400, 100,000 year cycles, 41,000 year cycles. I'm not going to go into the sort of astrophysics, but basically they play a key role in sort of spacing those interglacial glacial events. So they're about 100,000 years apart, essentially. Now, a million years ago, they were 41,000 years apart, and they transitioned from that to the 100,000 years over that time period. And that may have been one of the key drivers of this change, and also the Great Barrier Reef as well. So that increased aridity, we see rise in charcoal and a peak in ferns and grasses, and decline in colitis. Again, things are starting to dry up. Starts to really take off about 250,000 years ago. So dry rainforest decreases but recovers. Ferns decrease, and casuarina, she oaks, also decreases as well. And there's a change in the rainforest composition. So some pretty major changes. And then 170,000 years, our ferns further decline, palms decline, and podocarps decline as increase in grass. So all indicators of drier. Reason why I was brought in to sort of work on the ODP 820 record was this change at about 150,000 years. So basically, my PhD advisor, Peter Kershaw, handed me a box of samples, and they go with it, because he found this peak in charcoal, change in rainforest, and couldn't come up with an explanation. He said basically it's probably early human arrival. So people suggesting people were there about 150,000 years ago. So I looked at that, came up, we don't need to invoke people, but what we can suggest is that El Nino Southern Oscillation, so those El Nino La Nina years, so El Nino droughts, La Nina flooding events, basically drove the change, and suggested that sort of switched on around about maybe 500,000 years ago, and has increasingly become a much greater climate drive in the Australian climate, basically, and cause these changes. And even if you look at the change itself, so you see the decline in dry rainforest first, then the increase in eucalypt savanna, and then the burning. If it was people, you'd expect the burning first, then the vegetation change. So, just the basic change there is what we're seeing. If we look at 45 to 40,000 years, and we see another record, Lynch's crater, which shows the same change, that shows that burning first, then the vegetation change. And that's linked to people, and I think people definitely play a role. There's an interesting peak in mangroves, which might reflect increased soil erosion as well at that time period. And I mentioned that mangrove situation there, which I won't go into, but we do see extinction events. So Decridium capressinum, which is a New Zealand Decridium, and I can't remember, might be removed, I'm not sure, but it's a New Zealand species. Disappeared about 400,000 years ago in Northern Australia. Decridium guanamani, which is that pollen grain I showed you before from New Caledonia, disappeared about 20,000 years ago. And there's a species of spineless Asteraceae. So Asteraceae has spikes on it, regular pollen grains. This one has either very small spikes or no spikes at all, and that disappeared consistently probably around about 10 to 15,000 years ago across Australia. So as I mentioned, ENSOs seems to be the key driver of those earlier changes, basically influencing precipitation. So increasing aridity, but also increasing extreme events. So cyclones, flood events, and things like that. So we're seeing sort of while overall getting drier, there's increased variability overall basically there as well. So maybe enhanced rainfall during interglacials, more cyclones as well. So we think that transition, as I mentioned, it's called the mid-Pleistocene transition, was a key time period and sort of made our interglacial periods more extreme and basically enhanced rainfall during interglacials. And yeah, and I mentioned the GBR, Great Barrier Reef there as well, so I won't come back to that. We can also sort of hone in on the last 100,000 years and see what the continent or northern Australia may have looked like at that time period. And the interesting thing, so I've highlighted this time period, MIS 4, marine isotope stage 4. It was a glacial maxima event, so it's sort of relatively cool and dry. But we had a lot of native olives. So there we have a native olive species, Olea paniculata, which extends all the way from Pakistan, all the way through the Indonesian archipelago down to here. So it would have been a species that people would have been familiar with, and reflects dry rainforest, so probably associated with our bunya forest there as well. And then we saw savanna country there as well, so people probably would have been familiar with that, and existed there as well at that time period, depending on how quickly the spread was there. Interesting enough, there may have been a bit of a lag. We start to see burning really increasing about 50,000 years ago. Now, it may have taken 15,000 years ago, but if we look at the modelling, it should have only been about 5,000 years. But it may have taken that time for people to start to impact the environment. And there's also probably the influence of climate sort of sitting beneath there as well. So, if you have constantly wet or really dry conditions, the landscape mightn't burn. So there might be another climate situation sort of emerging there as well. I just want to point out the mangrove peak there. So mangroves love soil and mud. So basically, if you have increased fire, you have increased mud going down the river systems, great for mangrove habitat, basically. So that could be sort of a more subtle and indirect indicator of people being present there. I think I've summarized that. But yeah, basically, around that sort of 60,000, 70,000 time period, we do have environmental conditions for wet tropics favorable for people. We're seeing sort of potential impacts sort of emerging about 50,000 years. And that decline in Eric area was maybe 35 to 30,000 years as well. So sort of stages occurring in terms of landscape changes as well. And probably reflects a combination of both climate and human factors coming into play as well. So that probably sort of shows you where I sort of sit in the megafauna extinction debate. I don't think it's solely people. I don't think it's solely climate. I think it's a bit of both. And most scientists sort of suggest megafauna disappeared about 40,000 years ago. So if that's 60, 65,000 dates correct, you've got 25,000 years of overlap with people being here, living with megafauna. So I don't think people alone can explain it, but climate can't explain it because we've got hundreds of thousands of years of megafauna being there. What was different? People being in the landscape, basically. So you've probably seen the documentary that was on ABC last year, and they very much gave that view of climate. So I think people did play a role, but I think it was both coming to as well. So those sort of extreme climate events play a key factor. And we've done a little bit of work a little bit further south in central Queensland near Nebo. This is work I was involved with Scott Hocknell at Queensland Museum. And we're looking at a form of billabong that was home to saltwater crocodiles in this area. Basically, the fossils that we found, or that Scott found, I looked at the pollen, were basically the leftovers of the saltwater crocodile's meal as well. So it was a bit torn apart and things like that, but gave us enough to sort of provide information about what species were there as well, and gave us that 40,000 year date. So megafauna were sort of there, and then they didn't get past 40,000 years as well. So it suggests that it might have been a period of climate instability with overall more arid conditions as well. So Scott would probably sort of fit in with that climate as the key driver. But basically, that's the remains there. So lots of bits of teeth and sort of chewed on, gnawed on other bits of bone. You've got a variety of reptile species. So we did have Komodo dragons in Australia. We had a couple of other species of crocodiles. There was a land crocodile that was present there as well, which didn't make it through. Diprotodons and a whole range of the other marsupials that you would have seen as well. But basically, we have our dates about 40,000 years. Here's ODP 820 coming into the story. So basically increased burning and drop off in vegetation, which might reflect more open, drier landscapes, basically being a key factor in that as well, with people sort of influencing it in terms of hunting pressure as well at that time period. All right, so moving a bit closer to home. So I thought I'd sort of move down from sort of northwest to southeastern Queensland. This also, the rest of the talk will sort of focus on Minjerribah and the archaeology and palaeoecology there as well. This is work that's involved with Quandamooka Yulimbury Aboriginal Corporation, so very much front and centre in the research, and Everett Heritage as well, and UQ and a range of other partners as well, and still ongoing. So the dunes that we find around southeast Queensland, so Gari, Kalula, Stradbroke, Moreton, Minjerribah, and which are getting hit by the cyclone at the moment, are formed from longshore drifts. So basically we have sand coming up the eastern Australian coast, a lot of from Sydney, Minjerribah, transported here and basically deposited here under the influence of the southeasterly trade wind. So southeasterly trade wind sort of blow it onto the coast and then ramp it up on the coast. Work done by Jamie Schulmeister, a former president of the society. It's actually dated this process beginning between about 1.2 to 0.7 million years ago. So these are particularly from Kalula and Gari. We don't have a lot of dates from Stradbroke, but does reflect what we think is going on. And a similar story to what we see with the Great Barrier Reef. Now, the oldest dune sequences on the islands, and they're matched with the sort of chronostratigraphy, are Kalula, Awinya, and Yankee Jack. So these are hundreds of thousands of years old, basically. So these are the sites that we'll find the archaeology on. And if we look at Stradbroke here, I'll talk about a couple of records here, but certainly in the Yankee Jack and Awinya sequences. And the archaeological sites are also on the Awinya sequence as well. So we know the dunes are old enough to support the artifacts that are found there, basically. And this is a recent paper from Jamie, which sort of illustrates the Awinya formation. And yeah, Awinya there, and I think that's Yankee Jack there. So if I was looking for old archaeological sites on Gari, these are the areas I'd basically be looking at as well. So Stradbroke is really fortunate. We have a range of sites that go back 20,000 years plus, and these are just a lake. So that includes Boomerang or Brown Lake. I'll talk about a couple other records, so Fern Gully and Wellsby Lake, Lagoon, but also the wetland systems may also go back at that time period. And just want to sort of highlight what the coast looked like at that time period, 50,000 years ago. So Moreton Bay was completely dry. Stradbroke would have been similar to Kalula, and you would have probably had to walk another 20 to 30 k's to reach the coast basically there as well. So dramatically different environment. And I'll mention the Wallen site there, which is the first archaeological site. So this isn't a new site. So Neil and Stock investigated this in the 1980s and basically found evidence that went back about 27,000 years. This was the oldest site in Eastern Australia and basically reflected those changes. It was very controversial, and we revisited this in 2019, and I'll come back to that as well. But we also have a couple of other older sites here, so Wellsby Lagoon. Key take-home message there, similar story to Northern Australia, more rainforest dropping off. So the first thing I asked, is that a human signal? So are we seeing a change in landscape, people being and increasing fire frequencies there as well? And I know we're running out of time, so I'll speed up. Fern Gully, similar situation, basically rainforest declining at that time period, and that's something's happening there. Is that people? Reverse this, that's oldest there, youngest there, but basically see the green dropping off through there as well. So as I mentioned, we went back to Canalpin Creek. This is the Canalpin Creek excavation from a couple of years ago. You see a burnt tree stump, but these are where the artifacts are coming from. So sand's fantastic for preserving that as well. So Wallen was reinvestigated. It confirmed the 27,000 year date, but actually pushed it back here to around about 50,000 years. So we've got human occupation going back and continuous. So that's a number of artifacts there to 50,000 years, which is, yeah. So we've really pushed things back and added a dot right in the middle, basically, of that map I showed you before. Middle Canalpin Creek, similar story, around about 42 to 40,000 years ago. Two sites on the same island. And I suspect now we know what to look for. We'll find similar sites at Kalula, Moreton, probably Gari as well. That's what the artifacts look like. So very obvious stone tools. And there's some interesting changes in stone tools, which probably reflects changes in the environment. So you're going from a terrestrial environment to a marine environment. This is where we get middens, so shellfish, dugongs, and so on present in that as well. So I do have a record, pollen record close by at Native Companion Lagoon. And we do see increase in burning around 40,000 years ago, and interesting enough, an increase or change in burning around 5,000 years ago, which could be related to people, basically. So things are starting to come together, I guess, in terms of both the paleo and archaeological records as well. We can also look at the pollen from that site itself. And the key things you'll see is an increase in melaleuca and eucalyptus and grass over the last probably 20,000 years. If we go back to the last interglacial, we see a lot more Banksia, basically. So it suggests something different there. What's different? People and people impacting that landscape, and I think as well. This is an interesting record. So one of the things, dates are crucial for this. So probably about 6 months ago, I would have said that peak in eucalypts there, I think I've got there, was probably around about 12,000, 10,000 years old, and probably reflecting influence of people. My PhD student, Jody Schultz, working on this, has got some dates out. Base of that's only about 5,000 years old. So it's only out by a little bit there, basically. And there's changes in interpretation quite dramatically as well. People could well be involved there, but I think it's more of a sea level story occurring and wetland development than just straight human impacting the landscape. So it just shows you it's really important to have some caution with charcoal peaks as well. So the final site I'll just briefly mention is jumping grass. So jumping grass is actually on the old high school at Dunwich. It's now the kayak offices. And we've actually found some really interesting evidence from this site. So peats are the best sediment type to work on. So the peats that form your potting mix, and this is often where they come from, are really fantastic for pollen records. And basically we extracted a record from this. These dates I'd probably change a little bit, but I just want the general issue here is that we have more burning up until about 9,000 years ago, dropping off. And that reflects basically when Stradbroke was part of the mainland, we didn't have Moreton Bay. So we had more forests over Moreton Bay, more charcoal. And then basically when sea level rose, Moreton Bay developed, we didn't have that forest and burning sort of decreased as well. So again, lots of drivers there. So I've looked at the pollen. And again, I think the key driver that we have coming through here is basically sea level. So if you see the impacts of sheoaks, generally you can sort of actually equate it with major sea level shifts as well. But one of the really interesting aspects of it is that peak in peak in rainforest and changes in charcoal. What it suggests is that southeast Queensland was a really good refuge area. A lot of water during a dry period, a lot of water around, probably a lot of game, a lot of plant material, and would have been a perfect place for people to exist. And we've got the dates that sort of fit in with that as well. This is another core, probably about 200 metres away. And we see, and this is again the issues of if you have one record for one side, it mightn't apply to other records in that same site, particularly in these peatland systems. But we have evidence here of it's sort of a bit drier event, probably around about 6,000, 7,000 years ago. Very much this graph was basically, I developed it probably about 2 weeks ago, finished doing the counts. So more information as well. And we see the impacts of fire change from looking at satellite imagery or aerial photographs. So we have photographs that go back to the 1930s in southeast Queensland, a lot from the 1950s, post-Second World War. This is the area here. And I asked actually quite American people what they call this site, and they call it jumping grass. And you can see here, it's very open landscape. So that's 1 mile jetty. And you come in there, you've got all that mangrove, paper bark forest basically there. That's only taken off over the last probably 70 years. And that's as a result, and you can sort of see it starting to come in here at 67, but particularly there in 2017. That's taken out as a result of fire suppression. So it wasn't being burned on a regular basis. So paper bark takes over from your wire rush at that environment. And we're seeing that consistently across southeast Queensland, basically. So that's how fire and just removing fire can dramatically alter and impact the landscape as well. And we've mapped it, and we can see that maybe the whole swamp or marsh might disappear in the next 50, 60 years, basically because of that lack of fire as well. And we can see other evidence of this. This is 18-mile swamp. That's pre-European settlement. So you sort of see consistent changes in charcoal, which drops off with these really big peaks. So fuel loads build up, and we have the massive bushfires occurring basically there. And this is supported by the pollen record, which I'll show you shortly, but there are interesting changes in elemental content. Just want to point this little bit here in, I think that's zinc. And there's, I think, calcium's the other one that goes up there. Potentially a tsunami. So, and potentially could be linked to a cyclone. And interesting enough, Quandamooka have got stories about cyclones and tsunamis impacting these sites as well. So we can start to sort of work with First Nations people and sort of look at, you know, their dreaming stories and see how they operate as well. But again, basically, if we come back here, similar story with the pollen. So increased burning and quite dramatic vegetation change. So she oaks, but really coming back in this environment. And we've got one other core location. So we did ground penetrating radar, suggests maybe 9 to 15 meters of sediment, which might be a 150, 200,000 year record. So I'm planning to go back in July and extract a sediment core. I'll sort of summarize that, but probably the key message is 27,000 years of continuous peat deposition, which is pretty unique, 27,000 years plus. It's important carbon store, and there are some interesting changes in terms of fire use, which I've mentioned, but also southeast Queensland is a refuge area. So, you know, this is, I'd expect old sites here because it has water, and water is really important. So the other project that is sort of starting to develop is an Echo Lake Gari. This was a core that was collected in the 1990s by Maureen Longmore and a team from the Australian Nuclear Science and Technology Organisation. It's a 100,000 year record, and it looks to be continuous as well. So Justine Kemp from Griffith University has the core, and basically we're going to have a look at the last 60,000 years and see what we come up with. It's just located, let's see if I can find it, just here. Lake Balraddy's there, so it's sort of the middle part of the island. But again, another old record, that's the coring, pictures of the coring in the 1990s. This is a sort of coarse resolution record that Maureen produced. Basically, again, going from dry rainforest to heath eucalypt forest. So that similar trend that we're seeing there. And again, it's probably related to people basically. And we have dates going back 100,000 years. And basically, we think that 6 meters is basically 60,000 years. So something that I'm going to be looking at working on and getting some samples from Justine and sort of develop a bit further as well. And interesting changes in the wetland taxa. But I'm running out of time, so I'll summarize things. So we've got new records that have emerged from southeast Queensland that sort of fill that blank in terms of coastal Eastern Australia. We have 15,000 years of continuous occupation in this part of the world, and there will be more sites out there, and we just need to find them. Because of that positive moisture balance, so it's a wet, nice place to live. I've got people moving here all the time, and seems to be about 50,000 years old, people moving here and finding it quite nice. So it really acts as a really important refuge area in these periods of climate change. We've done similar work on koalas, and when we lower temperatures or increase temperatures, basically it comes to southeast Queensland for koala distribution. So there'll be a whole range of ecosystems and plants and animals that would utilize this area as well. So special area, I think everyone's probably aware of that, but sort of demonstrates, you know, some of the reasons behind it's special. And that information can help us develop management plans for these unique ecosystems, the species. So koalas are doing really well on Stradbroke. Again, if I take visitors across there, pretty much there's a koala at 1 mile. There's another one I've come across in a she oak in Flinders Beach, and there's one at Point Lookout as well. So, you know, these are probably key areas that we need to be aware of this wangari or dingo on Gari is the other one. We sort of see them as a really important refuge area. But also how people adapt to climate change. So we've got this 60,000 year record of people adapting to really dramatic climate change. So what they do, how can we use that knowledge to help us adapt to climate change moving forward as well? So I'll leave it there and happy to answer any questions as well.
Oh, thank you, Patrick. Such a lot to take in. But what a privilege to hear about this amazing research going back in depth so long, and that link between environmental change, vegetation work that Patrick is doing, and possible people in Eastern Australia. So anyway, questions. There must be lots of questions, I'm sure.
Hi, I'm just wondering, were there any obvious changes in vegetation following the mineral deposits from tsunami?
Haven't checked that yet, but that's a very good question. So yeah, we sort of develop new stories. So one of the things with pollen, it does take a long time to sort of do a sample. So generally it'd probably take me about a day to do or a couple of hours to do probably a sample, and that's someone who's pretty experienced now. Obviously students will take a lot longer for that as well. So to get those sort of finer scale changes, you need to do sort of really super high resolution analysis. They're probably there. I know I've done similar work, and actually I've done similar work in British Columbia on Eocene sediments. So these are 50 million year old sediments which actually map a volcanic eruption impact as well. So yes, there is potential to pick it up. We just haven't got the resolution of the pollen record at that level quite yet to see it.
Just wondering if in your studies in the periods, if there's been any account of the Earth's reversal in the magnetic fields?
Good question. So you probably saw the documentary on megafauna on ABC last year. I'm not sure whether you did. I think Colin Cooper was discussing the reversal or the weakening of the magnetic field. The Earth's magnetic field does reverse. The last time it reversed was around about 600,000 years ago to 500,000 years ago. It's called the Bruns-Minjerribah event. So if you got your compass out, it wouldn't point north, it actually points south. And that's recorded in iron particles in rock and things like that. But there have been a weakening of the Earth's magnetic field. And that's one suggestion that maybe that occurred 40,000 years ago. More cosmic radiation came in because we didn't have the Earth's magnetic field protecting us, or it wasn't as strong. And that may have sort of had a climatic impact and maybe impacted species and things like that. So I think it still needs to be investigated. It's interesting. I have some records that I've dated to 40,000 years ago, which have a lot of charcoal and tree branches and things like that. So something is happening there. It's not as obvious. That's one of the candidates there as well. And it's something we could experience in the next few hundred years. So there is evidence that the Earth's magnetic field is weakening. And the North Pole does move around. I actually saw a graph of this a couple of weeks ago, which basically said it was sort of further south. It's now sort of closer to the geographic North Pole. It's migrated probably around about a couple of hundred kilometers over that time period. So, and you can imagine not only those climate or environmental impacts, but all of our technology, compasses and GPS and things like that are dependent on that as well. And suddenly if it went south or wasn't there, you can imagine the impacts that would have on transport and things like
that. Just a couple of questions. We look mainly at land migration. Is there a possibility of sea migration? Rafts, boats,
oh, well, definitely to get into Australia, people would have needed to get on a boat.
Yeah.
And would have been fairly sophisticated at that time period. One of the things I didn't mention there, which I was going to, was what was the driver? Why did people feel a need? there was the Toba eruption around about 74,000 years ago. So this was a giant super volcano in Sumatra that erupted. We had ash falls as far as India, dramatic impact. There are suggestions in our DNA that's actually recorded that human populations crashed. And you can imagine if you're a person living in Indonesia at that time period, Toba goes up, you're probably going to go in whatever direction possible, basically get away from it. So that's one potential driver, or it could just be people saw smoke, birds, followed it, and then basically had the technology to get them over there.
But also would they have gone from Western Australia to Eastern Australia?
Oh, but probably not, but we don't know. I mean, they could well have migrated it down and around, but and if they're crossing in from Indonesia, they would have been sophisticated sea travelers. So it isn't out the realms of possibility. I think a lot of people think of it as land, but it could have also been following the coastline along and using their boats as well to get there. So.
Okay. Are you familiar with the idea of the Palaeoecological language family of Indigenous Australians?
Not directly.
Oh, well, I was just wondering if you would care to comment whether the.
Yeah. I mean, I know there's a lot of, so there's been some interesting work that have been involved in whether they've used linguistics in Gulf of Carpentaria to differentiate between different groups and arrival of different groups.
Yeah.
And it does fit in with the archaeology. But again, it is a problematic issue, not my area, so I don't want to take that as well. And we've got very diverse sets of languages across the continent as well, and I think that's really important to remember with First Nations people, that the variety of languages and the differences there, is quite dramatic and significant as well. So yeah.
You spoke about climate change taking place due to orbital issues, and it being happening quite fast. What sort of adaptations did the original inhabitants take? I mean, what did it make? Did it make them move? Did it?
Possibly, yeah. So I mean, again, basically, so if we look at the last 60,000 years, and I'll start with marine isotope stage 4, so it's going a little bit further back in time. But basically, that was what's a period called a glacial maxima. So this is when our ice sheets extended much further south in the northern hemisphere. Sea levels were much lower, more arid, although there is research challenging that in Australia. It's not as arid necessarily as we think it was. But basically, it's about, and marine isotope stage 2, which is about 20,000 years ago, is another glacial maxima. But it's about a 4 to 6 degree temperature difference, which is a lot. So if we sort of take the arid adapted situation, you would have seen your desert areas becoming much more arid, much drier, and probably much harder to exist in. And that probably would have pushed people towards the coast. But they also would have pushed them out onto those dry land areas. And then when sea levels start to rise, we would see people basically being pushed back as well. So obviously, we've had situations, and we have dreaming stories of that. So there's really Patrick Nunn from University of Sunshine Coast has done a lot of work with that, and he has worked with First Nations people and said, yep, we've had this event here. So we have these records going back thousands of years, potentially 15,000, 16,000 years. And actually, interesting enough, having a chat with one of the Quandamooka people at Kayak, and he said, oh yeah, we've got stories about hunting on Moreton Bay, and that's around about 7,000 to 8,000 years ago. So I guess the adaptations would have been probably very low population densities, ability to move. Although in saying that, and work that we're doing in Mythica country, so that's Birdsville area, is suggesting that we may have had forms of agriculture here as well. So basically, there's this Australian grain belt where people were sort of utilising grasses. We've got things which are used to designate agriculture, which is grinding stones for flour, and they're 30,000 years old. So, we have this sort of interesting, the Bruce Pascoe dark emu hypothesis. So I think probably flexibility, adapting in a variety of different ways to a range of different environments as well would have probably been the responses. And different ways to strain environment. I think we've got to be careful of and I think this is one of my bugbears with fire management in Australia. You can't apply what we do in Tasmania to what we do here in Southeast Queensland to what we do in the tropics. And it's probably having that understanding of the environment and environmental differences that is probably the key lesson we need to take as well.
Anyone else? Yes.
So just clarifying the dates around the farming.
So probably last 3,000 or 4,000 years, but we have what is often a common archaeological form of evidence of agriculture, which is grinding for flour. We have grinding stones down at Lake Munga, which are about 30,000 years old. I'm not saying they're doing agriculture, but they're doing things, making flour and things like that, that are, really moving towards that area as well. Yeah, and trade network. So there's a plant species called Pitchera, which is a narcotic, and there were trade networks established where it was trading from Birdsville and the Lake Eyre Basin as well. And just to sort of show those differences, so Birdsville, probably a number of people have been out there. Low probably about 100 people at Birdsville. We've got evidence of villages of probably 300 or 400 people living, First Nations people living in that environment, which to me suggests if they can have a greater carrying capacity than us, they must be doing something right in a very sort of climatically extreme environment. We had the boom bust of El Nino and La Nina years as well. So and maybe that agriculture. And the other area is the eel farming down in Victoria is the other one, which people may have heard of. Mm-hmm. So there's a lot of evidence starting to emerge of, and it's probably not how we imagine agriculture, but it's a form of subsistence. It's probably in different ways and different approaches.
Anyone else? No? Well, we might let Patrick off the hook here and have a bit of supper here, but look, I think we've been really privileged tonight to hear about this amazing research that's being done and throwing light on some really important questions really about the history of Australian settlement. Can I ask Patrick just one final thing? So if you could, and you're doing so many projects in so many places, but if you could have a big fund at this point, where would you think you would like to, what would you like?
Probably this part of the world. I mean, there's a lot. I mean, you sort of follow the money. So it's a lot of the reasons why I work in different areas. So it's what gets up and funded. But there's still a lot of work to be done in Southeast Queensland. It's easy to get to as well. It's literally a ferry ride across the Stradbroke, but Moreton hasn't been touched yet. Cooloola, there's a bit of work. Minjerribah hasn't been touched. Gari, it's a lot of work as well. So, and it's nice and convenient, I guess, as well. So.
Well, we look forward to hearing more about your work in Southeast Queensland. Just want to thank the people on Zoom tonight. Thank you for joining us. I hope you found it really interesting, as we all did here. So again, could you please join me in thanking Patrick for tonight?
Yes.